Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to tackle what is termed as binomial distribution. So what is termed as binomial distribution? Binomial distribution is just the generalization of what Bernoulli trials. So for binomial distribution, we observe an experiment n times. So for instance, let's say we are tossing a coin n times, and then tossing that coin n time, we are also observing the number of successes. Okay, that will be either heads or tail. So maybe we are going to toss our coin n times, and then the number of times our success, that is head, turns up, right? That is what we are going to observe. And then the second example will be maybe a sequence of n shot may result in a number of hits or miss. So here we are also going to maybe shoot a target, right? So we are going to shoot that target some number of times, right? And for that some number of times, we are also going to observe the number of times the shot hits the target and the number of times the shot missed the target. All these experiments are termed as binomial experiment. Okay, and then we have some conditions for binomial distribution. First, we are saying that the experiment consists of independent and identical trials. That is just telling us that the occurrence of one experiment does not affect the occurrence of the other. Okay, so this means that strictly they are independent. Okay, and the second one says that each trial results in one of the two outcomes. Each trial results in one of the two outcomes, cause the success or failure. Okay, yes. So let's say I'm shooting a target for the first time, right? If I hit the target, I am successful. That is the success. And if I miss the target, it means I'm a failure. Okay, so once I shot the target for the first time and I'm able to hit the target, that is termed as a success. But if I lose the target, it's a failure. So that is the reason why we are saying that under the condition, each trial results in one of the two outcomes. That is called a success or a failure. And then the third condition says that the probability of success in a single trial is P, right? So the probability of success here would P. And then this probability of success will not change from trial to trial. So when we move from trial 1 to trial 2, always the probability of success is strictly going to be equal, right? And the probability of failure here in a single trial 2 is equal to 1 minus P. This 2 is also going to remain the same from trial to trial. Okay, and the last condition says that the random variable of interest x is the number of success observed during n trials. Okay, yes. So that is the condition for the binomial distribution. So let's define binomial distribution mathematically with its PMF. Okay, we are saying that a random variable x has the binomial distribution with the number of trials n and the probability of success p. If probability of if the probability of x, that is a random variable, is equal to n combination x times p raised to the power s times 1 minus p raised to the power n minus x, where our x are integers, right? So you have positive integers, that is 0, 1, 2 up to n. Okay, yes. So sometimes we knowing the PMF, this is our PMF, we can be asked to also calculate for the mean, variance, the characteristics function, and the moment generating function of the binomial distribution. When we are asked, how are we going to explain that one too? So here, the expectation of x is equal to n times p, where the n is the number of observation and our p is the probability of success. And the variance here is equal to n times p times 1 minus p, where our n is the number of observation, p is the probability of success, and the 1 minus p is the 1 minus p is probability of failure. Okay, yes. So that is the mean and variance, how we are going to calculate for it. Okay, and then for the moment generating function, the moment generating function is just equal to p times e raised to the power t plus q all raised to the power n. That is the moment generating function. The p is the probability of success, the t, the e raised to the power t will be static there, and then q is the probability of failure. Okay, and our n is the number of observation. Okay, So for the characteristics function, which is this one, right? The characteristics function, which is phi of x. So the only different from the only way the characteristics function is different from the moment generating function is the I. So anywhere you see the moment generating function, once you introduce I at where you see the t, so it will be I times t. Once you introduce the I, that is termed as what? The characteristics function. So here the P is the probability of success, the Q is the probability of failure, and our N is what? The number of observations. So this is Statistics and Mathematics YouTube channel. Please don't forget to subscribe. In our next video, we are going to solve more examples on what? The binomial distribution. So please don't forget to watch that next video to help you, because once you have gotten the mathematics behind the binomial distribution, you have to get examples to better the understanding. Okay, bye, have a lovely day.